Hello everyone, welcome back to this video series on clinical SAS SDTM programming. In this video, we will see how to create demographics dataset of SDTM. So let us go to the specification and then see what are the variables that we are going to derive in this. So we have the list of variables and the labels are provided and the derivation logic is provided. So for demographics datasets, before that, let's quickly see what are the input datasets that we are going to use. So here is our base dataset, which is demog dataset, in which in the raw dataset itself, there is one record per subject and some demographics related information is collected. So we will be using this dataset as the base dataset and then add some additional variables to this dataset based on the derivations provided. So now let us come back to the specification. So here for study ID, it says from the raw demog dataset, we are being asked to use the value from study variable. And for domain, we are being asked to assign the text DM to the domain variable. For useID, we are being asked to derive it by concatenating the value of study and PT variables from demog dataset. And we are also asked to use a hyphen as a separator between these two variables values. And then for subjd, we are being asked to use the value from PT variable of demog dataset. And for RFSTDTC, so what is being said is, so this is dependent on the value present in RFXSTDTC. So let us first come to RFXSTDTC. So derive the datetime value of in ISO 8601 format by obtaining the earliest non-missing IPSTDT raw from IP admin dataset and also along with the date. So we are also being asked to use the time component, so which is present in a variable called IP SDTM underscore raw for the each subject where IP admin IP quantity raw is greater than 0. So basically for RFXSTDTC we are being asked to use IP admin dataset from which we are, as there are like this study involves multiple dosings, so for that we are being asked to use the earliest non-missing date of that. And one additional condition is that we have to check whether the quantity administered is greater than 0 or not. So we'll be creating RFXSTDTC in this way. So this RFXSTDTC is becoming a component of RFSTDTC. So we'll have to derive this first and then derive RFSTDTC. So for the subjects who have non-missing RFXSTDTC, we are being asked to use RFXSTDTC for RFSTDTC. Otherwise, if subject if RFXSTDTC is missing but the subject is randomized, so then assign the value of RAND DT underscore raw, which is randomization date raw present from enrollment dataset. So RFSTDTC is becoming a component. It has two components so far. So one is RFXSTDTC and the second one is randomization date from enrollment dataset. Otherwise, even if the randomization date randomization date is also null, we are being asked to populate it with the value from RFICDTC, which means so we should have three components: RFXSTDTC, RFICDTC, and randomization date from enrollment dataset. So we will see how those other variables are derived. So RFENDTC, we are being asked to use the value from EOSTDT underscore raw of EOS dataset from the record where EOS cat is equal to end of study. So we'll have to use this raw date value and convert it into ISO 8601 format from the rows where EOS cat is equal to end of study from EOS dataset. And we have seen RFXSTDTC already. So for RFXENDTC, we are being asked to populate it with the latest non-missing IPSTDT raw where IP quantity raw is greater than 0, and along with date we are also being asked to use the time component from IPSTTM raw. And for RFICDTC, we are being asked to use the raw date value from ICDT underscore raw from enrollment dataset and convert it into ISO 8601. So we have also seen that another variable called RANDT raw from enrollment was used as part of RFSTDTC. So when going through the specification, we'll have to understand these interdependencies. So enrollment, we need it for randomization date raw for RFSTDTC derivation, and we also need it for RFICDTC. So next variable is RFPE and DTC. So it is mentioned as derive the date value in ISO 8601 format by obtaining the latest date value from all datasets. And it also says date variables in dataset can be identified with the suffix of DT underscore raw. So we'll have to check all the available raw datasets, and then it is also mentioned that the date variables could be identified as DT underscore raw. So across all the DT underscore raw variables, whichever is having a latest value, so we'll have to use that value to populate RFP and DTC in this scenario. And then we have the derivation for depth DTC, which is DTH DTC, which says again to use EOSDT raw from EOS dataset, but from the record where EOS cat is equal to end of study and EOS term is equal to death. Again, we had a dependency of EOS somewhere. So where was it? EOS, we were using it for RFE and DTC. So again, we'll have to cross check if uh, we can derive dependent variables in one go when which are coming from the same data set. So this is how you can reduce your coding burden, or you can derive multiple things within the same logic if there is a dependency. So here we have completed the derivation for depth DTC, and the next one is DTHFL. It says assign as Y on the records where DTH DTC is not null. So for site ID, we are being asked to extract the first two characters from PT variable of demog dataset. And then for age variable, so we have age underscore raw in the input dataset demog, so we'll have to assign it to age variable. And for age raw age unit, so we are being asked to use the raw variable age underscore raw unit. And for sex variable, it says equals to the value from raw demog.sex after converting into standard control terminology. So for a sex variable, I think in the input dataset, the values are collected as male and female in full text, but as per the standard control terminology, M and F have to be presented for males and females respectively. So that's why it is mentioned that after converting to standard control terminology. So we'll have to map accordingly. And then for race, so it says derive SDTM race based on the values present in demog race 2, race 3, and race 4. So in this specific example which we are saying, so a subject can select, like if they feel that they belong to multiple races, they can choose different race values. So if a subject chooses multiple race values, so each of them will be marked separately in these variables. So if that is the case, we will have to select it as multiple. In the race variable, we'll have to present it as multiple, and then we'll have to make use of these variables and create some supplementary variables to populate the individual race values. Otherwise, if it's only one of them is selected, we can directly populate race variable in SDTM DM domain using the raw variables. And then for ethnicity, it says again use the value of ethnic from demog dataset after converting to standard control terminology. So and then we have the derivation for ArmCD, so which says derive ArmCD based on the information present in enrollment dataset and randomization datasets. So first thing we are being asked to use fetch the randomization number for each subject from rand_no variable from enrollment dataset, and then from the rand dataset txcd as armcd by joining the datasets based on randomization number and rand id. So we have created an exclusive video for how to create armcd using the same example. So if you are looking for in-depth understanding, please go through that video. It is available on the website under task section under SDTM general concepts. So after that, so part B says, so this part A is applicable only for the subjects who are actually randomized. So for them, the ArmCD can be obtained using the information from enrollment and RAND dataset. But for the subjects who are not randomized, we have to populate whether it has screen failure or not assigned. So this part B is talking about screen failures. So for the subject who has informed consent sign date as not null and enrollment date is null, so assign as screen failure. So which means the subject has signed the informed consent but is not enrolled. The subject is not enrolled into in this study. So if they meet, if they fail any of the inclusion exclusion criteria, so in that case, the enrollment date is left null. So for all those subjects, as they are screen failures, so we are being asked to populate as screen failure. And the part C is handling for the cases who are not randomized yet. So for subjects with enrollment date not null, and RANDT is null. So which means the subject signed the informed consent, met all the eligibility criteria, and the subject is considered as enrolled. So that's why we have enrollment DT as not null, but do not have the randomization date populated yet. So which means the subject is yet to be randomized and not assigned to any particular treatment, but the subject is not a screen failure. So we are being asked to populate it as not assigned with for those cases. So there can be cases wherein the subject may discontinue between the after having all uh, enrollment criteria met, but before randomization, or the it could be an ongoing case wherein the subject is yet to be randomized. In those cases, we'll have this not assigned populated in the ArmCD variable, which is planned ARM code. So for ARM, so it is an expansion of those for ArmCD wherever it is active. So we are being asked to populate it in prop case of active. For PBO, it is placebo. For SCR and fail, so we are being asked to populate it the full text of screen failure, and then not assigned, not ASSGN. In the ArmCD variable, we are being asked to elaborate it and present the full description of not assigned. And then for actual ArmCD, as we have again, we have an exclusive video on how to create actual ArmCD under task section under SDTM Gen on the website. So if you are looking for detailed explanation, so you can watch that video. So here if we see the again, I'll try to quickly cover this again. So derive SDTM DM actual ArmCD based on the information present in IP admin and box dataset. So under IP admin, we have the information related to the box from which the subject took medication in each of the doses. So under IP box ID, we have some coded box number, and we have a second dataset called box dataset in which we have a variable to store the actual content present in that box along with the box number. So we'll have to first identify the earliest box used by the subject, and then try to find out what is the content available in that box, and then use that information to populate our actual ArmCD. So fetch the IP box ID from the earliest record with non-missing IP quantity raw for each subject. So again, so I'll have to identify that pattern. So we used the IP raw from the earliest record with non-missing IP quantity raw or IP quantity raw greater than 0 for RFXSTDTC, which means it is the same record. IP raw from that record is being used to derive IP RFXSTDTC, but IP box ID is used to fetch the or create actual ArmCD variable. So we'll have to try to understand this relationship while reading the specification so that we can uh, reduce our coding steps. And then after that, we are being asked to use the value from content in the box dataset as actual ArmCD by joining the datasets based on IP box ID and raw.box.kit ID. And then for part B, so this is for the cases who took at least one dose. So there can be cases wherein the subject might be screen failures or not assigned or not treated yet. So for the subjects with SDTM ArmCD and screen failure are not assigned, assign the value from SDTM.DM ArmCD. So for screen failures and not assigned subjects, so it actual ArmCD is a copy of planned ArmCD. So for part C is talking about the subjects uh, who are, what is this? Subjects with RANDT not null, but RFXSTDTC is null. So we are asked to populate it with NOT-TRT, which is not treated. So the subject is randomized to a particular treatment, but is yet to take a dose. Then in that cases, we are being asked to populate it with not treated. So again, this actual ArmCD, we have that decode value. So ArmCD has the coded values for the actual arm. So actual arm has the decode values. So active, placebo, screen failure, not assigned, and not treated. So we'll be populating it based on the values present in actual ArmCD, which are listed here. And then for country variable, we are being asked to directly assign the value from country variable. For race one, so all these variables from here are part of our supplementary DM domain. So equals to the value from raw.demog.race. So when SDTM DM race is multiple after converting to standard control terminology. Similarly, so race2 is used to store the individual races of the subjects when the race is multiple. So because the subject might have chosen a particular race value under race variable and second value in race one variable. So for that parent SDTM DM, so we are calling it as multiple. So we will still have to capture the information of the individual races the subject has selected, and can we can capture those as part of supplementary domain. So we are using the QNAMs race 1, race 2, race 3, race 4 and so on to capture those individual race values selected. And then we, as per the study design, I think the selection of race is equal to other is also applicable, but when they are choosing the race as other, so they are being asked the question other specify. So that is captured in the variable called race SP in our demog dataset itself. So race SP is equivalent to the value present in the raw race SP variable. So now we have seen the specification for demographics dataset. We'll now go to the program aspect and then we'll try to see the intermediate datasets step by step. So the first step is what I'm doing here is I have my data code. I have the code that creates the input datasets for this lesson in a file called sdtmdm lcsg001 underscore data.sas. So I am building a macro variable to hold that path, and then I am including that particular file in this SAS program. So whenever this line gets executed, the entire code that is present in this .sas file gets executed. So which in turn means that all the datasets required for this lesson will be available for the subsequent processing. And then, so here I'm creating a copy of some of the important datasets. One is demog. I'm creating a copy and calling it as demog01. For IP admin, I'm calling it as IP admin01. For EOS, I'm calling it as EOS01. For enrollment, I'm creating a dataset called enrollment01. So we'll now move on to the next steps, which is consisting of the main demog variable or important variables derivation. So if we see the comment says create the ID variables and other variables which are directly dependent on raw variables without involving any major derivations. So some of the things we have seen in the specification, they are equivalents to the raw variables which are present in demog dataset or need some minor modifications or combining more than one variable into a single variable, such kind of things. So at the time of reading demog dataset, we have a variable called race in the input dataset, but we also need to create a variable in SDTM DM dataset race. So, but we have seen that the subject could select more than one race. So for that same reason, I am renaming it as race 0 to avoid any conflict. So here I am assigning the lengths for some of the required variables, which are of character in nature. And then for study ID variable, as per the specification, we were asked to use the value from study variable. So we are assigning it to that variable. So some programmers may prefer just renaming the study variable to study ID, but it's up to the programmer's preference. So here we are making the assignment. And for domain variable, we are being asked to assign the text DM in uppercase to the domain variable. So we are doing that here. And for subj ID, we were asked to use the value from PT. So we are assigning that. And for site ID, we were asked to extract the first two characters from PT variable. So we are making use of substrn function, or in fact, you can use substr function itself to extract the first two characters. So we specify from position 1. So we have to specify the length of the number of characters that we want to extract as the third argument. So which means, so from first position we are extracting two characters and storing it in site ID variable. And then for usubjd, we were asked to concatenate the values from study and PT variable with a hyphen in between. So catex function can be used for that purpose. So what it does is it adds the value of present in study variable and a hyphen in between, and then concatenates the value in PT variable. So, and the next thing that we are doing here is assigning country value to country variable. So when the when the input raw dataset contains the same named variable and there is no additional transformation required for the same named variable in SDTM, so we can ignore writing that assignment statements. But so some programmers prefer explicitly mentioning it, that so that they want to ensure that they have not missed creating any variables which are required for the SDTM domain. So again, so this is again optional, so it is programmer's preference. And for ethnicity, we were asked to convert it into control terminology, but based on the values present in the raw data set, so all we need to do is convert in the ethnic variable. So we are just applying the upcase function on the existing ethnicity variable. So just see the minor difference between these two variables. So here country needed no modification, but for ethnicity, so all we needed was that conversion to the uppercase. So we could have avoided writing this statement, but we would still have needed this. So though the input variable name is the same, but we needed a transformation. So we will have to make sure whether to come up with a personal preference on how you want to program them. So and then next thing that we are trying to do here is create the race variable. So we have renamed the original race variable to race 0. So we are using that race 0 here. So race 0, race 2, race 3, race 4, and then we are using CMIS function to check how many number of variables have missing values. So if CMIS function returns the number of variables which are passed to this list with missing values in it. So this has to be multiple when CMIS is less than 3, which means more than two variables are populated, greater than or is equal to two variables are populated. So the condition has to be checked for is less than 3. On those cases, we'll have to assign the value of multiple. So we'll take a quick look at the input data on which cases we'll have that. So here if we see for this subject 1002 race, which we have renamed as race 0. So race 0, race 2 both are populated. So for let's take a look at the first subject. So what happens when in that CMIS function is that we have specified four variables. So when processing for this first subject's data, CMIS function would return the value of 3 because three of the variables have missing values. So when processing for the second subject, so it returns a value of 2 because race 3 and race 4 are missing, which is two variables are missing. So which means whenever it is less than 3, so which means more than two variables are more than one variable is populated. So that is our requirement. Whenever more than one of the variables is populated, we were asked to populate it with multiple. So we are making use of that programming logic to populate it as multiple here. So and then in other cases where one of the variable could be populated, so we are making use of coalesce function. So what this coalesce C function does is it out of all these four variables, on which of the variable has a non-missing value, so that value would be picked. Say for example, if both race 0 and race 2 is populated, the value from race 0 would be picked and assigned to race variable. Say for example, if race 2 and race 3 are populated, but race 0 is missing. So what will happen is the first non-missing value encountered in this variable list of variables is from race 2. So the value from race 2 would be assigned to the race variable. So and then for race SP, this is a variable that is going and sitting in our supplementary domain. So we are just again this needed no transformation, but to ensure that I have not missed any of the variables derivation, so I am manually assigning the same variable to the same named variable here. And then for whenever race is multiple, so we were asked to populate race 1 value with the value from race 0, and for race 2 it was from race 2, and for race 3 the raw variable race 3, and for race 4 we were asked to use the value from race 4. So we are handling the creation of supplementary variables for uh, when the race is multiple in this section. And then for age raw, I think the date value was present. Age raw was present as a character variable in the input data. So as age is expected to be in the numeric format, in SDTM DM. So we are converting that into numeric format. And in the cases wherein age is not missing, so we are assigning the value from age raw U to age unit. So there can be cases wherein the collected age is missing. So as per the CDISC SDTM expectation, so we should not populate the unit when the age value is missing. So the same is in fact applicable in all the other findings domains. So when the original result or the standard result is missing, so we should not populate the associated unit variables. So the same case, so we are trying to populate AGU only on the cases where age is not missing. And then for sex variable, so we have seen in the specification that it was specified that we were asked to convert the existing or the collected values to standard control terminology. So here the values were collected as female and male. So but as per the standard control terminology, it has to be F and M. So we are handling that here. So we have now handled all the variables which are kind of direct copies or which need minor modifications without any dependencies on other datasets and derived them as part of DM01 dataset. So we'll now move on to the next step. So the next step what we are doing here is derive disposition related variables. So we have uh, enrollment dataset, EOS dataset, which are kind of considered as disposition related datasets in the raw dataset. So we are deriving variables which are dependent on these variables and these uh, raw disposition datasets. The first one is, so in this section what we are doing is informed consent date, enroll date and randomization date. So as part of the specification we have seen that we needed randomization date and also informed consent date while deriving RFSTDTC, and we needed enrollment date while creating our ArmCD and actual ArmCD variables. So all of them are coming from enrollment dataset. Instead of processing it separately for each of those cases, what I'm trying to do here is create the required variables in single step. So as all of them are present coming from the same dataset called enrollment. So we have created a copy of enrollment as enrollment01 at the top of this code. So here the requirement was to just convert for RFICDTC. So we had to convert ICDT underscore raw to ISO 8601 notation. So we are handling that using this syntax. So we are trying to convert the existing raw date value, which is in character format of date 11 type. So using input function to numeric first and then applying YYMMDD 10 dot format to convert it into ISO 8601. So we have discussed in the previous videos also that if we only have date component available or it is equivalent if we only have date component available in ISO 8601 notation. So it is equivalent to YYMMDD 10 dot format. So instead of using any fancy ISO 8601 or E8601 or those formats, we are making use of the existing simple YYMMDD 10 dot format for our programming purposes. So we have E8601 series format and so we are not making use of those formats. We can directly use the simple YYMMDD format. So again, there is no harm in using those formats, but these are programmers will be more familiar with these basic SAS formats. And similarly, I am creating a variable called enrldtc to store the information from enrldt underscore raw, and then a variable called randdtc from randdt underscore raw, and keeping only the study pt and the newly created raw variables in this dataset called RFICDTC. And in the next step, so we have another disposition dataset called EOS, so for which I have created a copy called as EOS01. So for RFE and DTC, we were asked to filter the records where EOS cat is equal to end of study. From that record, the value from EOST DT raw, we were asked to convert it into ISO 8601 format and then keep it in RFE and DTC. So we are subsetting the required records and then applying the required transformation on EOST DT raw and then creating our RFE and DTC variable here. So we have RFE and DTC derived, and then some of the components. RFICDTC is a direct variable which has to be created in SDTM domain. So ENRLDTC and RANDTC are kind of components that we'll have to reuse in subsequent steps. So we have derived these two pieces of information from enrollment dataset and EOS dataset. And then we have death rate. So in this case, we are being asked to derive death rate using the information from EOS dataset. So but consider the records where EOS cat is equal to end of study and EO term is equal to death. So out of all the end of study records, so only some of the records where EO term is equal to death will contribute to the death rate. So what we are doing here is we are uh, converting again EOSTDT raw into ISO 8601 format and storing the value in the variable called DTHDTC. So and again, so we as part of the specification we were asked to populate DTHFL is equal to Y on all the records where DTHDTC is not null. So we are creating that record and then keeping we are creating DTHFL variable as part of this step only and then keeping the required variables of study, PT, DTHDT and DTHFL. So end of study is considered as disposition dataset and then enrollment is also considered as a disposition dataset. That's why this section was labeled as derive disposition related variables. So now we have certain components coming from this. So we will use the information from these datasets in the subsequent steps and then derive some additional variables which are required in SDTM DM domain. And then we are processing exposure related information. So for exposure related information, kind of RFXST, DTC and other ARM and actual ArmCD, so we need this information. So we are reading IP admin dataset and for which we have created a copy as IP admin 01 and then we were asked to filter those rows where IP quantity raw is greater than 0. So we are subsetting those records by making use of a subsetting if statement here. So if input after converting it into numeric format, we are checking whether it is greater than 0. Only those rows which meet this condition will have all these statements get executed. And then for IPSTDT raw, for RFXSTDTC and RFXENDTC, we were asked to use the information from IPSTDT raw and IPSTTM raw. So if we take a look at the IP admin dataset here, the time values are not having that leading 0. So, but as per the ISO 8601 notation, so we'll have to add the leading 0 when the time component has that 0 absent. So for that purpose, what we are doing here is we are checking whether the length of IPSTTM raw greater than or is equal to 4. So if that is the case, we are trying to convert it into numeric value. And then, so in that, if that numeric time is not missing, so we are trying to convert it into character format using TOD 6 dot. So this TOD 6 dot in format or the format actually gives that leading 0 for time. So again, so here I have written this code with the assumption that the time values will not be partial. If the time values are partial, you will have to extract the hours and minutes separately and then try to convert or concatenate those individual components while creating the time. So as this is exposure information, so it is very unlikely that in any regular smaller studies that the dates or the times will be partial. So I am making use of that conversion of the existing time value and then into numeric and then you're making use of that numeric variable and converting it back into character value, but this time using TOD 6 dot format. So if you take a look at EXP01, we'll discuss this 3 lines of code and then see the EXP01 dataset and how this times is getting transformed to. And then we are checking whether time is present, both date and time are present. If that is the case, so we are converting the date value to ISO 8601 notation and then concatenating the delimiter T in between and then concatenating this transform time value. Otherwise, if only date is present, so we are converting directly it into ISO 8601 notation without the time component being concatenated. So if we take a look at the EXP01 dataset, where is it? Yeah, here if we see, so in the input data set we have seen that there was no leading 0, but we have transformed it into numeric and then converted it back to uh, character using TOD6 format. The TOD6 format, when the time value doesn't have that leading 0, it gives us that leading 0. Uh, why I'm stressing on the importance of TOD6 dot is when compared to time 5 dot is that time 5 format does not give you the leading 0. So but TOD6 dot actually gives us the leading zero for time. So this is the minor difference that we have to note, why I am not making use of time 5 dot but using TOD6 dot. And then here now we have just made sure that we are creating this temp DTC in ISO 8601 format from our exposure dataset. But we see that there are multiple records available for each subject. So, but for RFXST DTC, we had to use the latest of these datetime value, earliest of this datetime value, and for our RFXST DTC, we had to use latest of these datetime value for each of the subjects. So in the next steps, we'll do that. So here we are sorting the dataset based on study, PT, and temp DTC. So we might have discussed in some of the previous videos also the advantage of having dates presented in ISO 8601 notation, though they are in character format. When we sort that values, so the lowest values come on top and the highest values come at the end. So we are sorting the data within patient based on the ascending values of temp DTC. So in this case, so what happens on the first record, we will have the date corresponding to RFXST DTC, and on the last record, we'll have the date corresponding to RFXE and DTC. So here we are making use of the data steps feature to create multiple data sets within a single data step. So we are making use of first.pt. So we are subsetting the first record of each patient and then sending it to RFXST DTC, and subsetting the last record of each patient and then writing it to the RFXE and DTC dataset. So at the time of writing, so we are making use of rename is equal to dataset option to rename that temp DTC as RFXST DTC when creating RFXST DTC dataset. At the same time, when writing the record to RFXE and DTC, as this contains the record for last subject and the last date, so which in the temp DTC on that record is equivalent to our RFXE and DTC. So we are renaming them accordingly. So let us take a look at RFXST DTC and RFXE and DTC, which are created from that. So these are the first records from each of the for each of the patients, and these are the last records for each of the patient. So one thing to note here is that I have retained the IP box ID variable from in this dataset of RFXST DTC. So when we were reading the specification, we have seen that we will have to use the content from the box ID of the earliest record to populate our actual ArmCD. So here we need the box ID. So if we had not kept IP box ID, we had to repeat this entire processing uh, of fetching the earliest record within each subject for IP box ID again. But I am making use of this existing logic. So because I needed the IP box ID from the earliest record to create actual ArmCD, and I needed the date value on that record to populate RFXST DTC. So I am just keeping that variable here so that I could just reduce some programming. So next step is that we are creating our planned and actual arm related variables. So as the first step, we are creating our planned arm variable. So we have I'll quickly take you through the raw data sets so that it will become easy to follow through. So in the enrollment data set, for the subjects who are randomized, we have this variable called randomization number populated. So and we have a second data set called RAN data set. So in which the TXCD variable has the arm to which the subject is randomized to. So here we will have to know the randomization number for each subject, and then from that randomization number, so we'll have to fetch the value from TXCD as ArmCD for that subject. So this is kind of like joining it twice. From demog, we will have to, from enrollment, we'll have to know the randomization number. So we'll have to use the randomization number of that subject and then try to fetch the TXCD value as ArmCD for each of the patients. So now we'll come back to the program and then see how it is handled. So here the first thing is that we are using our enrollment dataset and filtering all the rows where randomization number is not missing, and we are keeping study, PT, and randomization number. So which means, so we are keeping the randomization number for each subject for the randomized subjects, and then we are sorting this subsetted dataset based on randomization number, and then we are using our RAN dataset. So here we have seen that the randomization number here is present in a variable called rand_no, but in RAND dataset it is present as RAND ID. So in order to merge these two datasets based on the randomization number, we'll have to rename or create a new variable such that it is common to both the randomization dataset and the enrollment dataset, the processed enrollment dataset. So in this step, what we are doing here is, so we are creating a variable called RAND number by assigning the value from RAND ID to it, so that we can join the dataset randomization and this RAND-NO dataset based on the values using RAND-NO variable. So here we have seen in the specification that we were asked to fetch the values present in TXCD as ArmCD. So I am creating a variable called ArmCD and assigning the values from TXCD. So ArmCD, ARM variable is can be derived using the values from ArmCD. So for ARM value, so we were asked to use the text active in prop case when ArmCD is active, so we are creating the ARM variable here. And for when ArmCD is equal to placebo, we were asked to use the value as placebo in full text. So here from this dataset, what we need is the variable ArmCD, ARM, and randomization number. So if you take a look at rand no one dataset, so we now have randomization number variable ArmCD and ARM. So now when we join this dataset to our processed RAND-NO dataset based on RAND-NO, so we will get the associated ArmCD and ARM for each of the subject. So here in this we have dataset, we have subject level information and their randomization number, and we in this the processed randomization dataset we have the ARM associated with each of the randomization number. So when we join these two datasets based on randomization number, we will be able to get the ARM for each of these subjects. So let's now see how that is handled. So in the next step, we have joined RAND-NO dataset and processed randomization dataset based on the values present in RAND-NO dataset, and then keeping all the records coming from RAND-NO dataset. And then we are keeping subject, PT, ArmCD, and ARM variables. So if we take a quick look at the ArmCD dataset, we will have the associated ARM for each of the subject. So as we don't need randomization number, I have dropped that variable from this. So this is how we populated our ArmCD and ARM. So in the next step, so we'll be deriving our actual ArmCD. So similar to how we have processed our randomization information, so we'll be making use of our RFXST dataset in which we kept the earliest IP box ID of each subject. So if we take a look at RFXST dataset, so we know this is the earliest box ID used by each of the subjects. So and then if we take a look at the box dataset, so we have all the box IDs that are used by the subjects in this dataset. So the content variable indicates the actual ARM for each of the subjects. So we'll have to join our RFXST dataset now to the box dataset based on this box or the kit ID values to fetch the content and populate our actual ARM values. So let's now come back and see how this is being handled. So this content variable is being used to populate our actual ARM. So here we are now creating values like if content is equal to active, again we are creating the variable actual ArmCD is equal to active and actual ARM as active in prop case, and similarly for content is equal to PBO, we are assigning the value of PBO to actual ArmCD and then the text placebo to actual ARM. So and then we also, if we notice, so the box ID value is present in a variable named kit ID here, but here in our RFXST the same information is present in a different named variable. So as we cannot merge these two datasets with two different variable names, so what we do is we create a common named variable. So that we are handling here in box01 dataset, we are creating the assigning the value of kit ID to a new variable named IP box ID so that we can join this to our RFXST using this IP box ID variable. So if we take a look at box01 dataset, so it has the information. So we have kit ID and that we have created this IP box ID variable by assigning these values to this variable, and then using this content variable we have created two variables, actual ArmCD and actual ARM. So when we now join this dataset to our RFXST based on the value of IP box ID, so we'll get the associated actual ARM values into based on the box ID used by the subject. So now see how that has been handled. So we have our box 01, we have sorted it based on IP box ID, and then we have sorted the RFXHT dataset and then called it actual ArmCD using the bivariables IP box ID. So now we are joining actual ArmCD01 to the box01 dataset based on IP box ID variable and then keeping only the required variables. If we take a look at IP box ID, I think what was the dataset? So it was actual ArmCD. If we now take a look at the actual ArmCD dataset, we'll have the actual ArmCD associated with each of the subject. Now we have completed this derivation of actual ArmCD. So what is the next step? So we are deriving our RFPE and DTC. For RFPE and DTC, what were we asked? We were asked to use the latest date value from all the date variables available across all the raw data sets. So here I have appended all the raw data sets which has a dt underscore raw variable. If we take a look at adverse event, so it had four different variables named AEST dt raw, AEN dt raw, so HADMT dt underscore raw, HDS dt underscore raw. So as I need to fetch all of this date information to a single named variable, when appending, I am renaming those individual variables to the common variable name date on all these rows. So when appended, what happens is all of these individual date values would be present in a common named variable. So I am appending all the other raw data sets which has a date variable, and in the next step what we do is we use this appended data set. So let's quickly take a look at the all date 01 data set, so which contains our all of the date values coming from different data set. So here if we see, there are some rows in which there were no the variable dt raw could be present in, but in that particular data set the individual date variable may have null values or partial dates. So we'll now see what has been done in the next step. So in the next step, so what we are doing here is we are trying to convert the source date variable to ISO 8601 notation. So here we are extracting the day variable. So again, I have made an explicit full length video to explain how to create ISO DT values from raw date values. So that can be again available under tasks SDTM Gen section of the website. So here we are trying to convert it into ISO 8601 notation, and then in the next step what we have done here is we have sorted the data based on study, PT and date C. So here we are only filtering those records where date C is not null. So let's take a look at all date 02 first, and then we'll take a look at the final all date 03. Here if we see, so these are all the intermediate variables that we were generating to create date in ISO 8601 format. Here if we see, there are some partial dates available, and then this is having all the date values for each of the subjects in across all raw data sets in ISO 8601 notation. So in the next step what we have done is, so we have sorted and then filtered only those rows where date C is not is equal to missing. So on the last record of each subject, as we have sorted the values based on ascending manner, we'll have our latest date. So we are filtering the latest date using this subsetting if statement and then making use of last.pt. So and then we are assigning the date C variable value to RFP and DTC and then keeping only the required variables. So if we take a look at now RFP and DTC dataset, we have the latest date across all data sets for each of the subject is present in this data set. So now we have kept one more variable ready in a separate data set. So what do we do next is that we have created multiple variables in separate raw data sets, and then we need to fetch all of them into a single data set. So we have seen that we have derived some of the variables which need some minor modifications and kept in a data set called DM01, and then we need to fetch all of the information present in these datasets into this DM01 dataset. So we are achieving that using a merge based on study PT. So whenever we are doing this merge, we just make sure that keep only the required variables from these datasets. So I have made sure that I am keeping only the required variables at the time of creation of this datasets itself. So some programmers, they do not use the keep statements here, but they may use keep is equal to option here. But I personally find them writing a keep statement in these individual data sets so that it becomes easy for me to cross check things. If something goes wrong, if I want to go back and check what is happening in each of those individual data sets. So in this step, I'm fetching all the intermediate variables or the final variables that are required for our SDTM DM programming. So now as part of the next step, what do we do? So we need to derive additional variables which are dependent on other derived variables. So far we have, if we quickly take a look at the example of ArmCD. So what we have done here is we were uh, able to populate actual ArmCD as active and placebo only. So, but in order to populate it as screen failure or not treated, or sorry, in order to populate that screen failure or not assigned in ArmCD variable, we needed to check whether the subjects in ICDTC is present, enrollment DTC is present, or uh, RANDTC is present or not. So what we have done here is we have only partially derived our ArmCD here, but we were getting the variables which are related, which are required for further derivation of ArmCD in this dataset called RFICDTC. So if we quickly take a look at the dataset called RFICDTC, so we have this RFICDTC, enrollment date, and RANDTC. So now, as we have joined all of these things, so we should now have all the information required for ArmCD variable derivation. Similarly, we needed some other variables for deriving other variables. So after we fetched all the intermediate variables that are required to derive other variables, we are jumping to the derivation of, or the new variables or completion of the derivation of the existing variables. So here, the first thing that we are doing here is to derive RFSTDTC. So as per the specification, the first thing that we had to check for RFSTDTC creation was to see if RFXSTDTC is present or not. If RFXSTDTC is present, so we were asked to populate it with the date component from RFXSTDTC. So in RFXSTDTC, we are having both date and time components. So I am making use of substr function to extract the first 10 characters and populate RFSTDTC. So after this assignment statement, so if I have RFSTDTC as null, so which means for the subjects who do not have an RFXSTDTC, after this line of code, we'll have it as missing. So if it is missing after this line of code, what I'm doing here is checking whether the subject's randomization date is not null. So if that is the case, so I am assigning the value from RANDTC to RFSTDTC. So again, so we have seen that we needed this intermediate variable for creating RFSTDTC, and we have kept it ready in a dataset called RFICDTC in a prior step and making use of that here to derive RFSTDTC. And then in the next step, what we are doing here is we are checking if RFSTDTC is missing, but randomization date is also missing. So in that case, we were asked to use the value from RFICDTC to populate RFSTDTC. So we have done that here in these two if then else statements. And then next we are trying to, so here we have solely created RFSTDTC newly in this step. So but for ArmCD, so we have partially derived it in a prior step and completing that derivation here. So if ArmCD is missing, so after all the derivation we have for the subjects who were treated, so we would have for the subjects who were randomized, we would have obtained ArmCD variable when we merge this ArmCD dataset to our DM01 dataset. But for the subjects who were not randomized, so we have to populate it as screen failure. So for that we have to check this condition. So after joining this dataset, if ArmCD is coming as missing for any subject, but for that subject even our enrollment date is also missing, so which means the subject signed the informed consent but was not enrolled, which is specified as like, which can be found as having the enrollment date null for that subject. So after the derivation, if ArmCD is coming as null and enrollment DTC is also null, so we are assigning the text SCR and fail to ArmCD. And for Arm variable, we are populating it as screen failure. And for screen failures, actual ArmCD also holds the value from ArmCD and Arm. So we are completing the derivation for actual ArmCD and actual Arm, and also ArmCD for the screen failures in this step. And in the next step, so what we are doing here is if ArmCD is null, but enrollment date is not null, but randomization date is null, which means the subject is yet to be randomized or the subject has not been assigned any treatment yet. So for those cases, so we are assigning the text not not ASSGN for ArmCD and assigning the full text of not assigned to ARM variable. And for these subjects, so actual ArmCD will be equivalent to this. And then we are finally completing the actual ArmCD and actual arm for the subjects who are randomized, which means for the subject who has an ArmCD populated and randomized, which means randomization date is not missing, but exposure start date is missing, which means the subject is randomized, but our exposure raw data does not have a record which indicates that the subject has taken a dose yet. So for those subjects, we are populating actual arm CD as not treated, actual arm CD as NOT TRT, and then the text not treated to actual arm variable. So here we have seen the case wherein we have explicitly derived a new variable using our input date variables or modified the logic for the previously created variables. So this happens in most of the cases even when you are creating ADSL dataset in your Adams or any other domains as well. So you will be able to individually or partially derive some information in a separate step and other half or other component in separate data steps. So you would get all those components together and then rederive or complete the derivation or the derive those variables newly using all the components. And then finally, what we are doing here is we are writing some attributes for all the parent variables which are supposed to be in DM domain and also for the variables or the QNAMs which have to go into uh, sub dataset. And then we are keeping only the required variables. And in order to create supplementary dataset, so we have created a variable called macro variable called subqual list. So, and to indicate that list of variables, where is it stored? Subqual list. So here we are assigning that we are specifying that these information present in these 5 variables have to go into subqual. So we are making use of the transpose approach to create subDM here. So I have created an explicit video under task SDTM section on how to create a supplementary dataset. So if you want to go through it, supplementary creation in detail, I suggest you to watch that video. So here we are making use of transpose approach to create supplementary dataset. So one thing to note here is that we are setting IDVAR and IDVAR val to explicitly to null here. So SDTM DM is the only domain in which IDVAR and IDVAR val will be null in supplementary domains. In all other domains, so IDVAR and IDVAR will take some values. So as there is no IDVAR or IDVAR, so because DM is a one record per subject domain. So when we will be easily be able to link our parent domain and subdomain at U sub JD level. But whereas in other domains, so it is one or more records per subject. So we'll not be able to merge the datasets at subject level. So there we need IDVAR and IDVAR values to be populated. So in most of the cases, so we use the values of sequence variable in IDVAR and the values present in sequence variable in IDVAR variables in other domains subdata sets. So we have now created supplementary dataset and then kept only the required variables. And then in the next step, we are storing as the permanent copies of these datasets and assigning a label for the datasets. And in the next steps, we are converting the datasets into XPT formats, which we can make use of to run P21 checks. So this completes our SDTM DM domain programming using SAS. So if we take a quick look at the output dataset, we have all the variables which are required in the parent domain and also the supplementary domain in this dataset. Again, there can be cases wherein some sponsors may prefer keeping the supplementary domains as variables in the final datasets and they call these datasets as plus datasets or plus SDTM datasets. And then uh, you may have macros to internally convert these additional variables which are not part of the standard SDTM datasets as QNAM at the time of submission. Thank you for watching and keep learning.